Okay, so you know that feeling, right? When you're just feeling blah, maybe a headache that just won't quit or a cough that just lingers, and you finally drag yourself to the doctor and bam, antibiotics. We've all been there. But have you ever stopped to think about what those little pills are actually doing once they're inside you?
It really is a hidden world, isn't it?
Totally. And that's what we're diving into today, going deep, and I mean deep, into the world of
We're
antibiotics.
talking molecular level, folks,
Yeah.
getting into the nitty-gritty of how these medications actually work.
And to guide us through this microscopic battlefield, I've got a resident bacteria expert with us.
Ready to wage war on those microbes.
So we're not just talking about, like, masking the symptoms here, are we? It's about wiping out those microscopic invaders completely.
Exactly. Antibiotics are specifically designed to target bacteria. And here's the key.
Yeah.
Without harming your own cells. It's a pretty amazing process when you think about it.
It's like having a secret weapon, right?
You could say that.
And speaking of secret weapons, we've got these incredible diagrams to help us on our mission today. They're from a French study, and they break down all the major antibiotic groups and their strategies for attack. It's like a playbook for understanding how these medications work on a deeper level.
They're really fascinating, actually.
So should we accept this mission? And I'm assuming, since you're already listening, you're on board.
Always up for a challenge.
Great. Our mission is to decode how antibiotics are classified, how they target bacteria, and why this whole antibiotic resistance thing is such a big deal these days.
It's a constant back and forth, you see, like a microscopic arms race. And understanding that, I think, is key to appreciating just how important it is to use antibiotics responsibly.
Okay, I am hooked. Where do we even begin with this whole cellular showdown? It's like something out of a movie.
Well, like any good general will tell you, you have to know your enemy. And in this case, the battlefield is the bacterial cell wall. It's crucial for their survival.
Their Achilles heel.
Precisely. Now, if you take a look at this diagram, you'll see that bacteria are broadly divided into two groups, gram-positive and gram-negative.
Oh yeah, those terms are vaguely familiar.
It's all coming back to you, I'm sure. It all comes down to the structure of their cell walls. Gram-positive bacteria have this thicker layer, more exposed, that's called peptidoglycan. Gram-negative bacteria, on the other hand, they have a thinner layer that's tucked between two membranes, almost like it's hiding.
Sneaky.
It is. And this difference in their armor, that's key, because some antibiotics are designed to exploit those structural weaknesses.
It's like choosing the right tool for the job. You wouldn't use a hammer when you need a screwdriver.
Now you're getting it. Now, to really delve into this, let's start with the pioneers of the antibiotic world, shall we? The beta-lactams.
Ah, yes. The beta-lactams, home of the one and only penicillin. It's like the OG bacteria buster. I can't imagine living in a time before penicillin. Like, just getting a cut could be a death sentence, right?
It's true. Antibiotics like penicillin absolutely revolutionized the field of medicine. And the way they work is quite elegant, really. Beta-lactams, they zero in on that cell wall we were just talking about. They interfere with the bacteria's ability to build and repair those protective walls. And without them.
No more fortress for those pesky bacteria.
Exactly.
And our handy-dandy diagrams, they actually break down all the different types of beta-lactams, right?
They do. Because, see, over time, scientists have developed different generations of beta-lactams, each one with a slightly different structure and target.
Okay, so walk us through it. What are the key players in this beta-lactam lineup?
Well, I've got the penicillins, of course, the ones that started it all.
Yep.
Then came the cephalosporins, followed by the carbapenems and monobactams.
It's like they keep coming up with new and improved versions.
In a way, yes. Because each generation was developed to overcome specific types of resistance that bacteria were starting to develop.
It really is that constant arms race you were talking about, isn't it? Scientists develop a new antibiotic, bacteria figure out a way to resist it, so scientists have to go back to the drawing board and come up with something even stronger.
And it's a constant battle. But what's amazing is these diagrams actually highlight when each of these groups was discovered, which I think just really highlights how science has evolved in response to these new challenges. You know, it speaks to human ingenuity, absolutely, but also to the incredible adaptability of bacteria. And we have to keep in mind that beta-lactams are just the tip of the iceberg, really. There's a whole arsenal of other antibiotics out there, each with its own unique way of targeting bacteria.
Okay, you've got my attention. Let's talk about some of these other antibiotic all-stars. Hit me with it. I'm ready.
So we're moving beyond the cell wall now. Remember how we were talking about bacteria needing to constantly build and repair their protective barriers? Well, there's this other group of antibiotics, glycopeptides. they also mess with that whole process. But they're sneakier about it.
Oh, sneaky. I like it. Tell me more. What makes them different from the beta-lactams?
Imagine you're building a brick wall, right? Beta-lactams are like that annoying friend who keeps coming by and knocking over your stack of bricks.
Yeah, I've got a few friends like that.
Right. But glycopeptides, they're more like the friend who secretly swaps out your mortar for chewing gum.
Oh, okay. Now that's just mean, but effective.
Exactly. The bricks are still there, but they just can't stick together properly.
So no more impenetrable fortress for those bacteria. But something tells me bacteria have a few tricks up their sleeves when it comes to dealing with these antibiotic attacks. Am I right?
Oh, absolutely. In this epic battle between bacteria and antibiotics, you see, bacteria have evolved some pretty amazing defense mechanisms.
Defense mechanisms, huh? Give me the microscopic lowdown. How do they
Oh.
fight back?
Well, one way is by becoming, well, basically impermeable. It's like, imagine a castle with walls so thick that absolutely nothing can penetrate them no matter how hard you try. Some bacteria have evolved to simply block antibiotics from entering their cells.
So they've basically learned to just shut the door in the face of antibiotics, but what about the antibiotics that actually make it inside the bacteria? They can still do some damage, right?
Well, that's where their next little trick comes in. Inactivation. Picture a spy, right? Disarming a bomb before it can explode. Some bacteria, they've developed this ability to produce these special enzymes that actually break down and deactivate those antibiotic molecules.
So they've learned to fight fire with fire.
That's a great way to put it.
Hmm.
They basically disarmed our truth.
Oh, sneaky little buggers. They lock us out and then disarm us. Do they have any other tricks up their microscopic sleeves?
Oh, they've got one more. They can actually modify the very target that the antibiotic is trying to hit. Imagine a lock, right? But it suddenly changes shape so your key no longer fits. Bacteria can actually alter the structure of their proteins, which are what the antibiotics need to bind to in order to work.
So they're like changing the locks on us constantly. It's kind of unsettling when you think about it. Like, they're always one step ahead, always adapting and evolving to outsmart our best defenses. It makes you wonder if we're fighting a losing battle.
It is a significant challenge, there's no doubt about it. But the key is understanding how they evolved this resistance in the first place. And that's how we can start to fight back.
So where do we go from here? How do bacteria even develop this resistance? Like, is it something we're doing?
It's a combination of factors, really. Some bacteria, they're naturally resistant to certain types of antibiotics. It's just in their genetic makeup.
So they're like born with that resistance,
Mhm.
survival of the fittest and all that.
Exactly. But then there are those bacteria that weren't dealt such a lucky hand, genetically speaking. They develop resistance through mutation.
Mutations, like in those X-Men movies.
Well, not quite that dramatic. But you see, every time bacteria multiply, there's a tiny chance that a random mutation will occur in their DNA. Most of the time, these mutations are either harmless or they might even harm the bacteria.
So it's a gamble for them then.
In a way, yes. But every once in a while, a mutation pops up that gives the bacteria a huge advantage, like the ability to resist a particular antibiotic. And that's when things can really get tricky.
It's like they hit the genetic jackpot.
That's a great way to put it. But here's where things get really interesting. Bacteria can actually share these resistance genes with each other.
Wait, what? They can do that? Like they're sharing the secret to defeating antibiotics? How does that even work? Do they like have tiny little meetings and exchange notes?
Huh? I wish it were that simple, although I'd love to see what that would look like. But it's actually through these things called plasmids, which are like tiny little, I think of them as like circular pieces of DNA, and they can carry genes that give the bacteria advantages, like antibiotic resistance. Bacteria can transfer these plasmids to each other through a process called conjugation.
So they're not just evolving on their own, they're sharing their newfound superpowers with all their friends, like a microscopic network of resistance. I told you, this is like something out of a spy thriller. But you've got to admit, this is some seriously scary stuff. What can we even do about this growing threat of antibiotic resistance? It's kind of terrifying if you really think about it.
It is a serious concern, there's no denying that. But we have to remember that antibiotics aren't a magic bullet. They're powerful tools, but they need to be used responsibly.
Responsibly. What does it even mean when it comes to antibiotics?
It means using the right antibiotic for the right infection only when it's truly necessary, and completing the full course of treatment even if you start feeling better before you've finished all your pills. It might sound simple, but these things can really help slow down the development of resistance.
Okay, That makes sense. We can't just expect antibiotics to fix everything, like it's some kind of cure-all for every sniffle or cough. But what about those superbugs we hear about in the news, the ones that are resistant to almost everything? Are we fighting a losing battle when it comes to those?
Well, they're a serious concern. I won't sugarcoat that. But it's not hopeless. We're not going down without a fight.
Okay, good. Because I was starting to get a little nervous. So what can we do? How do we fight back against these superbugs?
Well, it's a multi-pronged approach. One strategy is developing new antibiotics. Remember how we were talking about that arms race between scientists and bacteria? Well, scientists are hard at work developing new weapons for our arsenal.
That's reassuring, but I imagine it's not easy to stay one step ahead of these bacteria, is it?
It's a challenge for sure. Bacteria are incredibly adaptable. But scientists are getting creative. They're exploring entirely new sources for antibiotics, like plants, even the ocean.
Wow, the ocean. That's amazing. What will they think of next?
Right. And it's not just about finding new sources. There are also new approaches to drug development, like targeting very specific bacterial processes that are essential for their survival.
So it's like disrupting those key processes to stop the bacteria in their tracks.
Exactly. Cut off the head of the snake, so to speak. And there are even more strategies being explored, like phage therapy. Have you heard of that?
Phage therapy. No, what is that?
Well, it uses viruses to attack bacteria.
Viruses attacking bacteria. It's like using one of their enemies against them.
Precisely.
Wow, that's pretty wild. It seems like we need to be thinking outside the box to stay ahead of these superbugs. But new drugs, those are only part of the solution, right? We can't just expect science to solve this whole problem for us.
Absolutely not. This is where that whole idea of responsible antibiotic use comes into play. We all have a part to play in this.
Okay, so back to basics. What can everyday people like me actually do to make a difference in this fight?
It all starts with education. Just understanding what antibiotics are, what they treat, and when they're truly necessary. We've got to move away from this idea of antibiotics as a cure-all for every little sniffle.
So being more informed patients, advocating for ourselves, and knowing when to ask if an antibiotic is really necessary.
Exactly. And when we are prescribed antibiotics, it's crucial to follow our doctor's instructions to the letter. And that means taking the full course of antibiotics, even if you start to feel better before you've finished all the pills.
I'll admit, I've been guilty of that.
It's tempting, I know. But if you don't finish the full course, you risk those tougher bacteria surviving and multiplying.
So we're giving our bodies the best chance to win the fight by finishing all our medication.
Precisely. And of course, let's not forget about good hygiene practices. Things like washing our hands regularly and covering our coughs and sneezes can go a long way in preventing the spread of infections in the first place.
Simple, but so important.
Absolutely.
So it's really about a multi-pronged approach, isn't it? Developing new antibiotics, using our existing antibiotics wisely, and strengthening our own defenses to prevent infection in the first place.
Well said. You've summed it up perfectly.
This has been such an eye-opening deep dive. We've gone from those first incredible discoveries to the front lines of this microscopic battlefield, exploring the fascinating ways antibiotics work and how these bacteria are fighting back. And it's clear, the future of these life-saving drugs really depends on all of us, from the scientists to the healthcare providers, and yes, even everyday people like us.
It's a shared responsibility, and one we can't afford to ignore.
You're absolutely right. Well, that's all the time we have for today's deep dive into the world of antibiotics. But listener, I hope you learned something new today. And the next time you're prescribed antibiotics, I hope you'll remember this conversation. These medications are powerful tools, but it's up to all of us to use them responsibly to ensure they're still around for generations to come.